Hey everybody, my name is Brandon, and today I want to talk to you about how you can use LiniNum for local privilege escalation on a Linux system. Now, I know when I was starting out doing things like Hack the Box, a lot of people directed me towards using these local privilege escalation scripts like LiniNum, and I would run them, and the reports and all the output of it would be so long, I would have no idea what to do with the information. So today, what I want to do is use LiniNum, run it, get all that output data, and step through each section step by step and talk about how each part can be used for privilege escalation. So to get started, let's check out the GitHub repo for LiniNum. So we have that on screen here, and I'll paste the URL down below in the description so you can go ahead and check it out for yourself. It is a super useful tool. It's something that I still use to this day. It helped me through going through a lot of boxes on Hack the Box and throughout my whole OSCP experience. So what we have here is we are on Vuln 0, which is a box that my friend Eugene and I made a few weeks back. Currently, we have a shell as a low privilege user, and we are in the temp directory, and we have LiniNum on the machine. Now, before actually running LiniNum, what I would do is go to File and Preferences, go to the Behavior section, and make sure that your history is set something above 1,000. 1,000 is the default. I would recommend setting it to at least 2,000, or else the top of your LiniNum report is going to get cut off. So once you have that set, we can go ahead and actually run LiniNum. So we can do that. We're just going to do /lininum.sh, and this doesn't take very long to run, really only like 3 to 5 seconds. As you can see, it's already completed. So let's take a look at the top of the report, and we'll go through each section and talk about how we could use it for privilege escalation. So at the very beginning, we're going to see some of the system information, such as the kernel version. Now, this can be very useful if you're trying to find something like a kernel exploit. If you already have a shell on a machine and the kernel is vulnerable to some sort of kernel exploit, that can be a very simple way to get root. Then you're going to get some other information, such as the host name, which is just great for jotting down into your notes. Moving into the user and group section, you can see the UID and some of the group information about the current user that we have access to. Now, this can be very important for correlating different permissions together. For example, if you note that our UID is 0, then it doesn't matter if we aren't root. We have the same permissions as root because our UIDs are the same. And the same goes for the GID, or the group identification number. Now, it can be very important to take note of the groups that you are a member of. For example, if the user that you have access to is part of the SQL admin group, and there's another user that's in the SQL admin group, now that's just kind of like a bridge on the permission level of things that you might be able to access that are shared resources. Maybe you can both access some MySQL configs, and then from there, you could read those files with the group permissions and escalate your privileges that way. You could go from a www data user to a regular user, or maybe even to root. So it's very important to take note of your UID and the groups that you're a part of. Now, you're going to see some information like the users that have previously logged on or who are currently logged on. That can be very important to note because you might see some files or things changing on the box. You're not sure why that's happening. Well, it can be good to know that, there actually is somebody else on the machine, or you could take advantage of that. Like if they're in on a VNC session that's not encrypted, you might be able to hijack it, or all sorts of other things like that, depending on what users are also logged in at the same time as you. So moving down, we have some more of the group memberships. So again, we have a list of all the UIDs and the groups that everybody's a part of. This is an easy way to take note of all that and try to correlate some permissions together for different users and see how you might be able to move laterally or escalate your privileges throughout the machine. And then it takes note of some of the admin groups that are in here and the super user accounts. Now, typically root is the only super user, but this is not always the case. There might be another user who is a super user, so you could essentially get access as that user instead of root, and it will have the same effect for you. Now, moving down, we'll see all the commands that we can run sudo without supplying a password. This is super common to see as a privilege escalation method when you're going through things like Hack the Box, because basically this section shows you commands that you can run as root without needing a password, which is super valuable. You can see right now we can run sbin halt as root. I don't know of any privilege escalation methods that involve using that particular binary, but if you haven't seen GTFO bins, that's basically your bread and butter when you're looking for this stuff. If you can find a binary that you can run with passwordless sudo, and you find that binary in GTFO bins, pat yourself on the back, you've found your privilege escalation method. Now moving down, we're going to see some of the permissions on users' home directories. This seems like something that can be overlooked pretty often, but it's really important. So for example, if we have a shell as the conda user, like we do, and maybe there's another user called admin on the machine, right? Now, if we're able to actually go into their home directory and read their files, we could get all sorts of valuable information. Who knows what they have stored in that home directory, and they might even have SSH keys in there. And if you can read their SSH private keys, even if it has a password on it, you could crack that password. If there's no password on it, you could just copy that private key, SSH in as a user. So it's very important to take note of this section here with lax home directory permissions. The next thing we'll see is all of the environment variables. This is something that might seem a little strange to use for privilege escalation, but you never know what kind of information people are going to throw in environment variables. It's not uncommon to see things like API keys or AWS keys in environment variables that people use for things like automation. Another thing that's important to take note of is this path environment variable. This is where the machine's going to look to find all the binaries that you would typically run. So if you want to run the command cat, it's going to look in this first directory and then the next directory, so on and so forth. And the first one that it finds that's executable is going to be the one that is run. Moving down, we'll see some of the information about SE Linux and whether or not it is present or enabled. And this is something that's important to take note of because SE Linux, it stands for Security Enhanced Linux, if you're not aware. If this is enabled, it can be a real pain to navigate around the file system if it's configured properly, because it's going to limit the access that you have to all different things. So it will make sure that you only have access to the things that you really need access to, so it can make privilege escalation a real pain. Moving down, we're going to see some of the path information. So again, we just talked about what the path is for. Now this will show you if the directories in the path are writable or not. That's basically the thing to take note of here. And we can see that user local bin is writable to everybody. Now that actually is part of the privilege escalation in this box. So again, the path is something that's super important to take note of. If you haven't seen, I did do a video on how you can use a writable root path for privilege escalation. So if you want to learn more about that, go ahead and check that video out. Next, we're going to see the current UMask values. These are basically the default permissions that are used when a file is created on the system. So if you create a new file, the default permissions are going to be whatever the UMask values are. This could be important because if you see that maybe root is creating a new file and by default it's writable for everybody, then you might be able to write to that file after root has created it. And if it gets executed by a cron job or root just executes the file, then you can potentially run commands as root. The password and storage information is very important if you're targeting the etc shadow file and you're trying to crack hashes. So if you see that these passwords get rotated every few days and there's very long passwords, it might not be worth your while to crack it. And then you can also see the encryption methods for the etc shadow file. By default, it's usually SHA-512, but it might be a different method of encryption, and it could be easy to identify by this right here. The next section is for all of the cron jobs and scheduled tasks. Basically, these are commands or scripts that get run on a set time interval. So maybe every day, every hour, or custom time, these tasks will get run on a regular basis. This is super important to check. And again, this is the privilege escalation method for this box. So if we look in etc cron d, we can see that there is this path checker cron job, which is a custom cron job that we put onto the box. It's not something that comes by default. So whenever you see these custom cron jobs, you really want to take a look at them, see what they're doing. For example, this cron job is being run as root, and it leads to path hijacking. So if you were to actually open this up, see the contents of it, like we did in our Vuln0 walkthrough, then you could see how you could use it for privilege escalation. So always check cron jobs. They could be writable, or you could be able to write to a file that it calls, or maybe do some path hijacking, or all sorts of crazy stuff. So always check these cron jobs. All these other things down here, like the anacron jobs and the systemd timers, it's a similar concept where these are tasks that get executed on a regular basis, usually as root or another user, whatever is specified. But it's a very easy way to go through and get privilege escalation working if you can write to these cron jobs or interact with them in some other way that allows you to execute code. So let's see. Next is the networking section. This is super important because there might be services that are listening on localhost or a different adapter that you didn't see from the outside. So we can see that we just have our local loopback adapter and our regular adapter that we're connecting to. That's like our one Ethernet card on the box. But you might see some other adapters and some services that are listening on adapters you couldn't see. So it's important to take note of that to do some proper enumeration once you're on the box. Again, all this other networking information is the same kind of concept. You want to be taking a look at how this box may be interacting with other boxes, because that could also lead to privilege escalation. Moving down, we're going to see all of the listening TCP and UDP connections here. This is going to be much easier than running Nmap and taking a guess at what's listening on each port, because you can see directly what's running on each port and what interface it's running on. So for example, we can see that something is running only on the local host adapter and on port 25. So that's something we couldn't see from the outside, and it's now a new service that we had to play with. A lot of times you'll see things like databases running only on localhost, and once you have a shell on the machine, you can start to interact with that database, maybe pull some more information out of it once you're on the machine. So always take a look at the services that are only running on localhost or adapters that you didn't know about before. Moving down to the services, this is where it's going to list all the current services that are running and who they're running as. This is super important for enumeration, because you might be able to find all sorts of custom software that's running on the machine or things that you didn't see before. And if they're running as root, it can be a really easy way to exploit it. Now, this is a section where there's going to be a ton of information, a ton of services, and it's going to be hard to find what you're looking for, to be quite honest. I know when I first started out, I really didn't know what I was looking for looking through the services section. It was just kind of like a guess and check of, what's running on the box, what does this mean? I don't know. What I would recommend doing is get a list of whatever services typically run on the operating system and then cross-referencing. So, for example, if you're attacking an Ubuntu 2004 machine, boot one up on a VM and take note of all the processes that are typically running on that machine on a clean install, and then cross-reference the services that are running on the clean install to what you're seeing on the box you're attacking. That way you can see what things aren't default, and there might be things to look into in the future for privilege escalation. So let's see. This is a huge section, like I said. So we scroll down, there's all sorts of things. Here are all the binaries and their permissions from that list above. So anything that's running as a service, if you are able to maybe write to the binary and it's running as root, maybe when the service gets restarted, it will execute some arbitrary code that you put into it as root. So you can see a lot of these, well, all of them, they're not writable, and that's for a good reason. If we could write to, the actual bash binary, then we could make root execute some arbitrary code whenever it tries to run bash, and so on and so forth. Now, these symlinks, even though they're writable, it's not going to be the same, because these are just symbolic links. They're not actually making it so you can write to the binary itself. So that might be a rabbit hole you chase for a little bit, but it's usually nothing to worry about. So moving down, we're going to see some of the information about the etc and init binaries. Now, basically, these are the binaries and scripts that get run on boot, and they can be run by different users, but a lot of times they are run as root. So anytime that we see something that's running as root and we are able to write to it, that's typically a privilege escalation method, right? So if you see any of these binaries here in initd that you are actually able to write to, you can see none of these here have write permission for other, so we're not able to write to them. But if we were, whenever this machine gets rebooted, it will run these etc and initd binaries, and they will be run as root. So if you can write to it, you can control what runs, and of course, you could do something like spawn a reverse shell, add a new user, put your SSH key in place, whatever you choose to do to actually get access as root. So moving down to the system configs, these are basically all of the configs for these services that are running on the box. And if any of these service config files are writable by you and they're run by root, of course that can lead to methods of privilege escalation, but it's going to vary largely depending on each service. So if you find a writable config file, I would recommend doing some research into that service, how it interprets that config file, and see what you can do to kind of mess around with it, maybe get some arbitrary code execution. But really, again, what you want to be looking for is if any of these are writable and run by root. So there's a long list of them here. And again, this is another section where you can just kind of get lost in, especially starting out when you don't know what you're looking for. So it can be very confusing at first. The next section that LiniNum is going to tell us about is the installed software and the versions of software that it's running. This can lead to things like discovering CVEs and software. That can be a very quick method of getting RCE or some other exploit working. So it's going to list, the sudo version, which I know that about a year ago there was a sudo privilege escalation method just from the installed version of sudo that was by default on machines. So just checking things like that. Plug it into ExploitDB, do some Googling. Google for sudo version 1823 exploit and see what you can find. It's all about doing some enumeration and some recon. Same thing with Apache. You never know what CVEs are going to be out there. Always take a look. Even if you think, oh, this is a safe version, I've seen this before a couple months ago, always check. There's new exploits coming out every day. You never know what's going to be out there. Now, for the installed Apache modules, again, it's the same thing with all this installed software. Take a look if there's any published exploits available for the different software that's out there or the different modules that are in software, because not only should you check for the Apache version, right? Maybe Apache is safe and it's not vulnerable, but maybe one of the modules that it uses here is vulnerable to some attack. That happens all the time. Maybe you find a WordPress server and WordPress is patched and there's nothing wrong with WordPress, but maybe the plugin that they have installed on the server is vulnerable, so you can exploit that plugin. That's definitely something you should always look out for. Now moving down, we're going to see a list of interesting files. This is a section where you're going to find a lot of interesting things, such as files you would use to put data on the machine or get data out, like wget and curl. Things like GCC would be listed here, or anything that might be useful to you as an attacker. Now pay attention to this next section. Can we read or write to sensitive files? Super easy to overlook this. This is going to be the permissions on etc password, shadow, things like that. These files that really make up the users and groups of the machine. If you see that etc password is writable to anybody, you can just add yourself a new user with UID 0, whatever password you want, and then you have a root account on the machine. And same thing goes for all these other sensitive files here. If you can write to them, you own the machine. So really take a close look, take note of the permissions here. That's one of the big problems when you're running these scripts, right? Is it gives you so much output, you just kind of skim through it, but you really can't. You have to read this thoroughly. Read every word, every symbol of it, or you're going to miss something, and it's not useful running the script at all. Moving down, we're going to see a list of the setuid files. These are files that no matter who invokes them, they run with the permissions of the owner of the file. So all of these are owned by root. So no matter who invokes any of these binaries here that are owned by root and setuid, they will always run as root. Again, GTFO bins is going to be your bread and butter for this. If you find a binary here that is setuid, owned by root, and it's on GTFO bins, you've pretty much got your privilege escalation sorted out for you. They give some awesome walkthroughs on how to use each of the binaries to privilege escalate to root. Set group ID files is the same kind of concept, except instead of running as the user that owns it, they run as the group who owns it. Again, use GTFO bins for this section. For any files you find, always cross-reference things that you find on GTFO bins because they add new things there all the time, so it's something to take note of. Alright, so next we have files with POSIX capabilities set. Now this is basically another way of looking at permissions and like special permissions that can be assigned to files. I would do a little bit of research into what each of these mean, but you can see that there's different capabilities here like setuid and setgid that can be used for privilege escalation the same way SUID files and GUID files would be used, but they might not show up in these lists above. So take a look into those files that are here and the POSIX capabilities that are set. Now next we're going to see a list of like all the different config files. For example, here's a list of the NFS config details. If you haven't seen, I've shown an example of how you can use the NFS no root squash option for privilege escalation. So NFS can be something that can be used to get root in a machine. If you haven't seen that video, again, I'd recommend checking that out so you can learn how to perform that privilege escalation technique. Now, again, we're going to see a list of all the config files which we have access to read or write to. Now, it's important to take a look at all these config files which you can read because you never know what you're going to find in them. Maybe you find some sort of HTTP config file for a web server, but it might make some SQL connections, and in that, it might have some plain text credentials in it. So a lot of times in these config files, you'll find things like credentials, or if you can write to them, you can actually change how the service runs, maybe what it does, and use that for privilege escalation. But again, it's going to widely depend on which service is running. But always go through, read these config files, especially the ones that are not standard on a machine, and see which ones you have write access to. So next we're going to see all of the user history files. This can be useful to see what commands the user was running before you got a shell on the machine. Maybe you can see some passwords that they entered in plain text or the files that they were interacting with to get some hints on what they're actually doing on the machine. The next thing we see is the location and contents of the bash history file. Again, that's important for the reasons that we just talked about. The next thing that we're going to see is the contents of the etc NS switch config file or the backup file of it. This can be used for some DNS attacks or things where you're spoofing another machine that may interact with the current one that you're on. So that can be useful for services that are kind of tied between two different machines going back and forth or things like that. And finally, the last thing that it will show you is any mail files that are in var mail. These are user mailboxes. So for example, if you're able to read the mailbox of root, maybe you'll find some sensitive information in there, or maybe for other users as well. It doesn't always have to apply to root. You might be escalating your privileges from one user to another before you can get to root. That's something that's very common to see. And that's basically the end of all of the contents of LiniNum. So I hope this helped you get a better idea of what you should be doing with the outputs of these scripts. I know it can be super daunting to look at when you first start out because basically you get this wall of text and you're just thinking to yourself, what am I supposed to do with all this information? There's so much to it. So I know when I started out, I'd always just skim through it and I had no idea what I was looking for. But hopefully this helped to clarify some of that so you can go through, actually read these reports like they're a book, word for word, symbol for symbol, see what everything means, and use it for privilege escalation. So good luck out there. Thank you for watching. If you found this helpful, please leave a like down below and subscribe for more content. I'll see you next time.